So what if an AI could read an entire book? Not by going word by word, but by just looking at each page as a single image. It sounds a little like science fiction, right? Well, that's the wild idea behind a new paper from DeepSeek-AI, and, it might just solve one of the biggest problems we have in AI today.
It's a really weird paradox when you think about it. Our most advanced AI models can create breathtaking art, they can write sophisticated code, they can even chat with us. But the moment you give them a really long document, like a novel or a super detailed financial report, they just kind of choke.
And here's why. The problem is a technical bottleneck called quadratic scaling. Now that sounds complicated, but the idea is simple. If you double the length of the text you give an AI, the amount of work it has to do doesn't just double, it quadruples. This creates this just massive computational wall that makes it incredibly slow and expensive to analyze anything long.
And this isn't just my take. The researchers at DeepSeek-AI say it right in their paper. They identified this computational wall as the central challenge that's holding these models back from really diving into the huge world of human knowledge stored in books and long documents.
So this led them to a pretty radical idea. They asked, what if we stopped trying to force the AI to read like a human, word by word? What if instead we could just show it a picture of the page and it could understand everything all at once?
They call this concept optical compression, and it's a really clever way to flip the problem on its head. Instead of a page being a long string of words to read, the AI sees it as a single, highly compressed image. Think of it like a zip file for text. The AI's job is just to learn how to unzip that visual information back into language.
And the efficiency gain here is, well, it's staggering. A single page of text that might take an AI, say, 1,000 or more little data points or text tokens to process, can now be represented by just a few hundred visual ones. That is a huge reduction in the amount of information the model has to juggle. Okay, so great idea. But how do you actually build something like that? Well, you can't just grab a model off the shelf. They had to design a completely new one from the ground up, specifically for this task. And they call it DeepSeek-OCR. Now, the architecture they came up with is purpose-built for this pretty unique job. It's not just a vision model and a language model kind of bolted together. No, this is a fully integrated system designed from scratch around this whole idea of compressing text into an image.
At its core, it's really a two-part system. First, you've got the DeepEncoder. Think of it as the eyes. It looks at a high-res image of the page and very cleverly squishes all of that visual info down into a tiny set of vision tokens. Then, the decoder, which is the brain, takes those compressed tokens and reconstructs them back into perfect, structured text.
But the real magic is in how that DeepEncoder sees the page. It's this brilliant two-step process. First, one part does a quick scan, almost like zooming way in to see the fine details and the shapes of every single letter. Then, it aggressively compresses all that detail by 16 times and feeds it to a second component that zooms way out to see the big picture, the page layout, the columns, the whole structure. This whole process makes it both incredibly fast and super accurate.
So that's the theory, right? And that's the architecture. But the real question is always, does it actually work? Well, they put it to the test. And honestly, the results are pretty amazing.
The model's performance is just incredible. It can take a picture of a page and rebuild the original text with this level of accuracy, 97%. I mean, that's already really impressive on its own, but then you see how it's doing it.
And here's the kicker. It's getting that near-perfect accuracy while using 10 times less data. That is a massive, massive leap in efficiency.
And you can see that advantage playing out right here on this chart. On a standard industry benchmark, even the small version of DeepSeek-OCR, using just 100 vision tokens, is outperforming a competitor that needs more than double that. And their bigger model? It achieves top-of-the-line performance, beating out models that are using literally thousands of tokens. It is doing so much more with so much less. But here's what makes this really special. The model isn't just transcribing letters. Because it's literally seeing the page, it can understand the structure and the context of the information in a way that just blows past simple text recognition. The researchers call it deep parsing. So, for example, you can show it a complex bar chart from a financial report. It doesn't just see a picture. It understands the bars, the labels, the axes, and it can pull all of that out into a perfectly clean, structured data table. Or, get this, it can look at a scientific diagram, like a chemical formula, and translate it directly into the special, machine-readable format that scientists actually use for their research. I mean, that is incredibly powerful.
And this isn't just an English-only tool. Its abilities are global. The model was trained on documents in almost 100 different languages, and it can handle these really complex layouts, from right-to-left Arabic script to intricate Asian characters with just remarkable precision.
So let's just zoom out for a second. What does all of this mean? Because this is way more than just a better way to do OCR. This whole approach could fundamentally change how we build and use artificial intelligence.
So, to sum it up, this research gives us a powerful new way to handle long text with state-of-the-art results using a fraction of the resources. But you know what the most impactful thing might be? It's so efficient that it can be turned into a massive data engine. It could automatically scan and structure millions of books, creating these incredible, high-quality datasets to train the next generation of even more powerful AI.
And the authors themselves put it perfectly. They say, this isn't just an improvement, it's a new paradigm. It really forces us to rethink the whole relationship between seeing and reading, showing how they can be combined to solve problems we've always thought of as belonging just to the world of text.
Which leaves us with this really fascinating question to think about. If an AI can absorb the entire content of a page as a single visual snapshot, what does that unlock? I mean, imagine being able to instantly digitize and understand every book in a historical archive, or an entire scientific library. This idea, this optical compression, it isn't just a clever trick. It might just be the master key that finally unlocks the vast library of human knowledge for artificial intelligence.